Now, when we talk about operations on functions and what we can do with multiple functions, we can add, subtract, multiply, divide functions. We can do anything at all, thank you, that we want to functions. So we could do any operations at all. So, for example, if we have, say, f of x is equal to x plus 3, and g of x is equal to 2x minus 1, we can say, I want f plus g, which means I want to add these two functions together. So in order to do this, all you have to do is set up the function for f, which is x plus 3, plus the function for g, which is 2x minus 1. So all you have to do, there's f, there's g. Now you could have even set it up in a different way. You could have set it up where it would be x plus 3, and then you get 2x minus 1, and then you add, and set it up vertically. I don't care which way you do it, it's just as long as you follow the rules. Remember, mathematics is all about logic, it's all about following the rules, it's all about keeping everything nice and consistent, doing things that make sense. And when you're talking about operations like this, then we're just going to do what kind of makes sense. You add the stuff that makes up the f function, then you add up the stuff that makes up the g function. So if you do this, how many x's do we have? Yep, so we have 3x, which we would have got from here. X plus 2x is 3x. What's 3 plus a negative 1, or 3 minus 1? Yeah, that's a positive 2. So in this case, f plus g is equal to 3x plus 2. And now you have a new function that you can do a lot of different things with. Now, the nice thing about this is this has a lot of different applications in the real world where you have different processes that you're going to have. Say you're talking about inventory, and you have a function that's talking about, and you're running like a phone store, and you have a function that's going to dictate how many Apple phones you're going to get and how many Samsung phones you're going to get and how many of this. You can actually add them together to figure out your total by adding each function together. Now, I doubt that's how that's actually done, but there are many different applications that are similar to that in manufacturing, as far as inventory coming in and coming out. Another thing, do you know what profit is? How you calculate profit? How do you spell revenue? Is there an E at the end of that?
It's fine if you misspell your math teacher.
I can't. So revenue, how much money you bring in minus cost. And you might have a function for revenue. So this might be R of x minus C of x. And this might be your profit function. So this is two functions that you subtract together. That's a very common type of situation there. So you might have to add functions together, subtract functions together, anything like that. And you'll be in business with that. Now, with these two functions, if I say, what's f times g? What would I end up multiplying? couple different ways you could do this. You can FOIL it, you can do double distribution, you could do anything you want to. I like to use the area model because how it works with factoring and multiplying. That's x plus 3. Have you seen this model before? Okay, where you just multiply. It's not a Punnett square. It's the area model for multiplication. 2x times x is 2x squared. X times negative 1 is negative x. 2x times 3 is 6x. 3 times negative 1 is negative 3. Add up the common terms, the x squareds. Usually everything's on the diagonal. So we'll get 2x squared plus 5x minus 3. You could have FOILed. If you FOIL, you do the first terms, which would be 2x squared. Then you do the outer terms, that's negative x. The inner terms, plus 6x. Outer terms, or the last terms, that's minus 3. Then you got to add up those guys together. 2x squared plus 5x minus 3. Hey, look, same thing. So does it matter? No, doesn't really. If you don't like that way, there's always this way too. X plus 3 times 2x minus 1. Negative 1 times 3 is a negative 3. That's a negative x. 2x times 3, that's a 6x. And that's a 2x squared. Negative 3, 5x, and 2x squared. So however you like to multiply stuff together, go right ahead and do that. That's fine. So, the moral of this story is that you can add, subtract, multiply, divide. You can do whatever you need to do, as long as you set everything up the right way. If I want f divided by g, what's going to go in the top? Or what's f? X plus 3. What's g? Now, here's a question. What can x not be equal to? Let me make that a little bit bigger. What can't we divide by? Right. You can't divide by 0. So this whole thing here, 2x minus 1, cannot equal 0. If x was 0, you'd have a negative 1 down there and we'd still be in business because you're not dividing by 0. But add a 1 to both sides. So 2x cannot be equal to 1. Divide by 2. X cannot be equal to 1/2. If x is equal to 1/2, we can't plug that in and get a real answer. So that might be a question that you get. All right. Come up with f divided by g and find out the restrictions on x. So that's a good restriction there. Yep. Restrictions on the domain, that's the only x value that won't work. Everything else is going to work perfectly. Now, here's another example. What if I said, Well, for this, I needed f of g, or f divided by g. We figured that out, x plus 3 divided by 2x minus 1. And there might be a follow-on question that says, hey, what x is going to make this undefined? That's your restriction. That's the one that's going to screw everything up. That's your answer. This is kind of part of it, because then I know what I can't use. So this is a restriction on the domain. So whenever you're dividing or wherever you have anything in the denominator, you want to make sure that you know what value you can't use. And if you can't use it, you can't use it. It's not that big a deal. It's not bad or good or anything like that. We never associate bad or good to anything that we're doing here. We're just associating facts to this. The fact is, I can use every x except for 1/2. Alright, same thing. I'll put this here. F of x is equal to x plus 3. G of x is equal to 2x minus 1. And I want to evaluate this at 4. Now, what does this mean? If you see that 4 out like this. No. You don't multiply it by 4. This means that x equals 4. To get a numeric answer. What's going to happen is we're going to get a number for our answer. Now let's check a couple ways that we can do this. Now let's do f plus g. Just do f plus g. Didn't we already figure that out? Well, that's x plus 3 plus 2x minus 1, which is 3x plus 2. Now, if I want the answer at 4, where do you think I put the 4? In for x, absolutely. So we want x equal to 4, so if 3 times 4 plus 2, what's 3 times 4? 12 plus 2, which is 14. So I got an answer of 14 here. Well, what if I took this and did f of 4 plus g of 4? Would that get us the same answer? Well, let's find out. Probably. I would say probably. But let's make sure. So f of 4 is going to be 4 plus 3. I'm going to add that on to g of 4, which would be 2 times 4 minus 1. So this is going to, what's 4 plus 3? 7 plus 8 minus 1, which is 7, which is 14. So, apparently there are two ways that we can do this. We can figure out f plus g and then sub in x equals 4, or do f of 4 plus g of 4 and get whatever our number is as our answer. So either way. Now, there are benefits to doing this, because if we're just doing one number, this might be the easiest way to do it. Just plug it into one function, get the answer, plug it into the other function, get the answer, and then do the operation that they say. That might be the easiest way to do it. If you have multiple x's that you have to plug in, This way might be the easiest because then we get like 3x plus 2, and then we just start plugging in the numbers here. If I needed for x equals 4, 10, 15, and 19, I want to figure out this, the 3x plus 2, so I don't have to plug it into f and g and then add them together. I kind of already did the adding f and g together, and now all I have to do is plug in the value, substitute in the value, and I can go. So if you're going to do multiple, values of x, that method is, I think, the easiest way, or it's the way that's going to set it up to be easiest for you. For one value, either way is good. For one value, either way is going to work out. Depends on how much extra work you want to do. This one has a little bit extra work to do because you got to plug it into two different functions. This one, you only have to plug it into one function.